Assalamu alaikum students, I am Ghazanfar, your chemistry tutor, and welcome to Mdcat Chemistry crash course. And today we are going to talk about the reactions of alkanes. Firstly, we are going to talk about the alkanes. What are alkanes and some important points that are relating to alkanes. Carbon-carbon bond length is 1.54 angstrom, and 1 angstrom is equal to 10 to the power minus 10 meter. And the carbon hydrogen bond length in alkanes is 1.112 angstrom, and 1 angstrom is equal to 10 to the power minus 10 meter. In alkanes, the hybridization is sp3. They show sp3 hybridization. So the bond angle for alkanes is 109.28 degree. This is the bond angle for alkanes. As the alkanes has sp3 hybridization, so they show tetrahedral geometry. They have tetrahedral geometry, and they are called paraffins. They are called paraffins. Why they are called paraffins? They are called paraffins because they are the saturated aliphatic hydrocarbons, and all the valencies of carbon are fully satisfied in alkanes. That's why they are least reactive. So due to the factor that they are least reactive, they are called paraffins. Paraffin means they are least reactive. The two factors that tells us about the reactivity of the alkanes is that one is the inertness of sigma bond. One is the inertness of sigma bond, and second is the non-polar nature of bonds. So these two factors tell us that the alkanes are paraffins. They are least reactive due to the non-polar nature of bonds, and due to the inertness of sigma bonds they are least reactive. That's why they are called paraffins. तो अभी तक हमने बात की है कि alkanes are the saturated aliphatic hydrocarbons. The carbon-carbon bond length in alkanes is 1.54 angstrom, and 1 angstrom is equal to 10 to the power minus 10 meter. And the carbon-hydrogen bond length in alkanes is 1.112 angstrom. That's why they show sp3 hybridization, and the bond angle is 109.28 degree. They have tetrahedral geometry, and they are called paraffins because they are least reactive, because all the valencies of carbon are fully satisfied, and due to the inertness of sigma bonds and due to the non-polar nature of the bonds. For example, if we take the example of methane, that is the simplest alkane, there are only sigma bonds present, and sigma bond is formed by the head-to-head overlapping. So they are the strong bond. इन्हें break करने के लिए हमें बहुत ज़्यादा energy चाहिए. That's why due to the inertness of sigma bond and due to the non-polar nature of bonds, there is a very negligible electron activity difference between the carbon and hydrogen. That's why they are non-polar. So due to the inertness of sigma bond and due to the non-polar nature of bonds, the alkanes are called paraffins. They are least reactive. Meaning under normal conditions, alkane does not react with the chemical reagents. For example, if we have alkane and we react it with the concentrated hydrochloric acid under normal condition, then there is no reaction takes place because the alkanes are highly least reactive. ये बहुत ज़्यादा least reactive है. Unreactivity की वजह से नॉर्मल कंडीशंस में ये हाइड्रोक्लोरिक एसिड के साथ रिएक्ट नहीं करते. Alkanes when react with concentrated hydrochloric acid under normal conditions, then there is no reaction takes place. And if the alkanes are treated with concentrated nitric acid, then there is no reaction takes place. If we treat the alkanes with KMNO4, then there is no reaction takes place. Similarly, if we treat the alkanes with another chemical agent, that is the K2Cr2O7, that is potassium dichromate, then there is no reaction takes place. It means that under normal conditions the alkane does not react with any chemical reagent like concentrated hydrochloric acid, concentrated sulfuric acid, concentrated nitric acid, KMnO4, potassium chromate, or K2Cr2O7. So these are the factors, two factors that tell us that the alkanes are least reactive due to the inertness of sigma bond and due to the non-polar nature of bonds. So alkane does not react with these chemical reagents under normal condition, but under suitable conditions, alkanes give a limited reactions. They give substitution reactions, they give oxidation reactions, they give thermal reactions. Alkanes give substitution reaction, oxidation reaction and thermal reaction, but they give these reaction under the suitable condition. जब हम कोई suitable condition लगाएंगे, कोई कैटालिस्ट ऐड करेंगे, टेम्परेचर इंक्रीज करेंगे, प्रेशर देंगे, तब ये हमें सब्स्टिट्यूशन रिएक्शन, ऑक्सीडेशन रिएक्शन एंड थर्मल रिएक्शंस देगा. सो सब्स्टिट्यूशन रिएक्शंस आर नाइट्रेशन, सल्फोनेशन, halogenation. Alkanes give nitration, sulfonation and halogenation under the suitable condition, that are the substitution reaction. Then these reactions follow the free radical mechanism. These substitution reactions follow the free radical mechanism. And it gives oxidation reactions. The oxidation reactions are the catalytic oxidation, incomplete oxidation and complete oxidation. Catalytic, complete and incomplete oxidation. Alkanes give incomplete oxidation reactions, complete oxidation reaction and the catalytic oxidation reaction. The complete oxidation is also known as combustion, but under these suitable conditions. Thermal reactions, alkanes give thermal reactions like pyrolysis or cracking. So alkanes are the saturated aliphatic hydrocarbons. The carbon-carbon bond length in alkanes is 1.54 ancestron. The carbon-hydrogen bond length in alkanes is 1.112 ancestron. sp3 hybridization 109.28 degree. Bond angle tetrahedrogeometry, they are called paraffins. So they are least reactive due to the inertness of sigma bond, due to the non-polar nature of bonds. Alkanes does not react with any chemical reagent under ordinary conditions, and they give certain reactions under the suitable conditions. Under the suitable conditions, they give substitution reactions, that are nitration, sulfonation, halogenation. They give oxidation reactions, incomplete oxidation, complete oxidation or catalytic oxidation. And they give thermal reactions, pyrolysis and cracking. It means that the alkanes give certain reactions at high temperature in the presence of sunlight or in the presence of ultraviolet light by absorbing light. So these are the some important points related to the alkanes. Now we are going to start our main topic, that are the reactions of alkanes. That are the nitration, sulfonation, halogenation, complete oxidation, incomplete oxidation, catalytic oxidation and pyrolysis. So our main topic is reactions of alkanes. Reactions of alkanes. So we start from the substitution reactions. So alkanes give substitution reaction, and these substitution reactions follow the free radical mechanism. So firstly we discuss the halogenation. What is halogenation? In alkanes, when the alkanes are treated with the halogens, the hydrogen atom of alkane is replaced by the halogen group. जब हम किसी भी अल्केन को किसी हैलोजन के साथ ट्रीट करवाते हैं तो हाइड्रोजन एटम जो अल्केन का है वो हैलोजन ग्रुप के साथ रिप्लेस हो जाता है. दैट इज कॉल्ड हैलोजिनेशन. बट द हैलोजिनेशन takes place in the presence of sunlight. Reaction takes place in the presence of sunlight or ultraviolet light or at high temperature. As we said that the alkanes reactions give under the suitable condition. These are the suitable conditions. They give reaction in the presence of sunlight, ultraviolet light at high temperature. So the order of reactivity of alkanes. Order of reactivity of halogens. The fluorines are more reactive as compared to chlorines, and the chlorination is more reactive as compared to the bromination. गलत हो गया. The order of reactivity of halogens. Fluorines are more reactive as compared to chlorines, and chlorines are more reactive as compared to the bromine, and bromine is more reactive as compared to the iodine. So this is the order of reactivity of halogens. The reactions of fluorine are violent, out of control, and the reactions of iodine are very slow. And these are the reversible reactions. So that there are two favorable reactions that the halogens give. One is the chlorination and second is the bromination. The chlorination and bromination are the favorable reactions. So this is the halogenation. Now we are going to talk about the free radical mechanism. What is free radical mechanism? As I said, the alkanes give substitution reaction, then they follow the free radical mechanism. Free radical mechanism is that mechanism in which free radicals are formed, in which the reaction accomplished via the free radicals. For example, we have a chlorine, and in the presence of ultraviolet light or sunlight, homolysis takes place. It means that free radicals are formed. There is a free radical here and free radical here. In the presence of sunlight or ultraviolet light, this bond breaks and one free radical goes to this chlorine and one free radical goes to this chlorine. So two free radicals are formed. So the reaction is accomplished via free radical mechanism, and this is a rate determining step, and it is an endothermic step, because in this reaction we provide the sunlight or ultraviolet light. Firstly, we discuss the chlorination of methane. Firstly, we discuss reactions, then we are going to move towards the mechanisms. Reactions of methane with the halogens. This is the methane. We treat the methane with chlorine in the presence of sunlight or ultraviolet light. Then there is formation of chloromethane takes place. In the next step, we again do chlorination in the presence of sunlight or ultraviolet light or at high temperature. Then there is formation of dichloromethane. In the next step, again we do chlorination in the presence of sunlight or ultraviolet light. Then there is formation of trichloromethane. In the next step, we again do chlorination in the presence of sunlight, ultraviolet light or at high temperature. Then there is formation of tetrachloromethane और इसको हम कार्बन टेट्राक्लोराइड भी कहते हैं. There is formation of carbon tetrachloride or tetrachloromethane. So this is the reaction, that is the chlorination of methane. Now we discuss the mechanism of this reaction. Free radical mechanism of this reaction. Free radical mechanism. Free radical mechanism. The first step, that is initiation. The first step is initiation. We have chlorine, and in the presence of sunlight or ultraviolet light, homolysis takes place. Homolysis takes place. Free radicals are formed. Free radicals are formed. This is called homolysis. In homolysis, free radicals are formed. And this step is endothermic. Endothermic plus it is the rate determining step, because this step is very slow step. This step is very slow step. The first step, that is initiation, is very slow step. That's why it is the rate determining step, and we give the energy. That's why it is endothermic process. It is the endothermic reaction, the initiation. The second is the propagation. Second is the propagation. In propagation, the propagation is the fastest step and it is the longest step. Fast plus longest step. In propagation, the free radical that is formed in the initiation proceeds the reaction. We have a methane. We do its reaction with the chlorine, free radical. Then there is homolysis takes place. Free radicals are formed. The bond breaks from here, and one free radical, the second free radical, and there is formation of methyl free radical plus hydrogen chloride. In the next step, this methyl free radical reacts with chlorine. So there are free radicals are present, homolysis takes place. One free radical here, second free radical here. This chlorine free radical reacts with this methyl free radical and form chloromethane, and forms chloromethane with chlorine free radical. So this product is formed. That is our chloromethane. In the next step, this chlorine free radical in the presence of sunlight, homolysis takes place, the bond breaks, one free radical here, second free radical here. This hydrogen free radical and this chlorine free radical reacts, and there is formation of this free radical and HCl eliminated. In the next step, we add chlorine in the presence of sunlight. Again homolysis takes place and the bond breaks. One free radical here, second free radical here, the bond breaks here, and this chlorine free radical and this free radical reacts, and there is formation of dichloromethane with chlorine free radical. In the next step, this hydrogen, the bond between this carbon and hydrogen breaks, homolysis takes place in the presence of sunlight, and this hydrogen free radical and this chlorine free radical combines, and the HCl eliminated, and there is formation of a free radical. This free radical is formed. And here the product is dichloromethane. This product is formed. Second product is formed, that is dichloromethane. In the next step, this free radical reacts with chlorine in the presence of sunlight. Homolysis takes place. Bond breaks. One free radical here, second free radical here. This free radical and one chlorine free radical reacts, and there is formation of a trichloromethane with chlorine free radical. Trichloromethane is formed. In the next step, again homolysis takes place. The bond between this carbon and hydrogen breaks, and the hydrogen free radical and this chlorine free radical react, HCl eliminated, and there is formation of a free radical. In the next step, we add chlorine. Again homolysis takes place. Free radicals are formed. Homolysis takes place. This chlorine free radical and this free radical combines, if we extend this step, there is a chlorine and a free radical and one free radical. This free radical and this free radical combines, and there is formation of a tetrachloromethane, that is called carbon tetrachloride, and a chlorine free radical is formed. Carbon tetrachloride is formed. So this is the free radical mechanism, and this is the second step, that is the propagation. The last step is called termination. The third step is termination. When the methyl free radical and chlorine free radical combines, then termination takes place. Methyl chloride is formed, and this step is exothermic, plus this step is very fast. Exothermic plus very fast. Now we are going to start the chlorination of ethane. Firstly, we discussed the chlorination of methane. Now we discuss the chlorination of ethane. This is the ethane, we do chlorination of ethane in the presence of sunlight or ultraviolet light. Then there is formation of chloroethane, HCl eliminated. Then again we do chlorination. Then there is formation of dichloroethane. In the next step we again do chlorination. Then there is formation of trichloroethane. In the next step we again do chlorination. Then there is formation of tetrachloroethane. In the next step, reaction takes place in the presence of sunlight or at high temperature. We again do chlorination in the presence of light. Then there is formation of pentachloroethane. Then there is formation of pentachloroethane. And in the last step, we again add chlorination. We do chlorination in the presence of light. Then there is formation of hexachloroethane. So here the hexachloroethane is formed, and that is the chlorination of ethane. This is our final product. How many products are formed in this reaction? Number 1, number 2, number 3, number 4, number 5 and number 6. So total 6 products are formed in this reaction. 6 products are formed in this reaction. Number 1, number 2, number 3, number 4, number 5, number 6. So this is the reaction for the chlorination of ethane. Now we discuss the free radical mechanism for the chlorination of ethane. Free radical mechanism. Free radical mechanism for chlorination of ethane. So in the first step, that is our initiation step. First step is the initiation. That is our endothermic and the rate determining step. It is endothermic plus rate determining step because it is a very slow step. In the first step, we have chlorine. In the presence of sunlight, homolysis takes place. Chlorine free radicals are formed. In this next step, that is second step, that is propagation. We have ethane and chlorine free radical. In the first step, the bond between this carbon and hydrogen breaks. Free radicals are formed. This hydrogen free radical and chlorine free radical reacts and HCl eliminated, and there is formation of ethyl free radical. There is formation of ethyl free radical. In the next step, this ethyl free radical undergo chlorination in the presence of sunlight. Again, homolysis takes place. The bond between these two chlorine breaks and free radicals are formed. This chlorine free radical and this ethyl free radical reacts, and there is formation of chloroethane and chlorine free radical. In the next step, this chlorine free radical and this hydrogen free radical, when this bond breaks, free radicals are formed, and this chlorine free radical and this hydrogen free radical reacts, HCl eliminated, and there is formation of this free radical. In the next step, we again add chlorine. Reaction takes place in the presence of sunlight or ultraviolet light, and homolysis takes place. This bond breaks, free radicals are formed. This free radical and this chlorine free radical reacts, and there is formation of dichloroethane with chlorine free radical. In the next step, the bond between this hydrogen and carbon breaks, homolysis takes place, free radicals are formed, and this chlorine free radical and this hydrogen free radical reacts, HCl eliminated, and there is formation of a free radical. This free radical undergoes chlorination in the next step. This free radical we add chlorine. In the presence of sunlight, homolysis takes place, free radicals are formed, this free radical and this one chlorine free radical reacts, and there is formation of trichloroethane, and a chlorine free radical is formed. In the next step, again homolysis takes place. The bond between this carbon homolysis takes place, the bond between this carbon and hydrogen breaks, and this chlorine free radical and this hydrogen reacts, HCl eliminated, and there is formation of a free radical. In the next step, we add chlorine. In the presence of sunlight, homolysis takes place. The bond between this chlorine breaks, free radicals are formed, this chlorine free radical and this free radical reacts, and there is formation of tetrachloroethane, and a free radical is formed. In the next step, again homolysis takes place. The bond between this hydrogen and this carbon breaks, free radicals are formed. The hydrogen free radical and this chlorine free radical reacts, and there is formation of this free radical, HCl eliminated. In the next step, we again add chlorine. This bond breaks when in the presence of sunlight or ultraviolet light at a high temperature, homolysis takes place, free radicals are formed. This chlorine free radical and this chlorine free radical and this free radical reacts, and there is formation of pentachloroethane. This pentachloroethane is formed with the chlorine free radical. In the next step, this chlorine free radical reacts in the presence of sunlight. Again homolysis takes place. The bond between this carbon and hydrogen breaks, free radicals are formed. This hydrogen free radical and this chlorine free radical reacts, and there is formation of this free radical with HCl. We again add in this free radical a chlorine molecule, HCl eliminated, we add chlorine. In the presence of sunlight, reaction takes place. The bond between these chlorine breaks, free radicals are formed. This chlorine free radical and this free radical reacts, and there is formation of it is a CCl3. It is CCl3. There is formation of hexachloroethane. This is called hexachloroethane, and a chlorine free radical is formed. This is called propagation step. That is our second step. And the last step is termination. Last step is called termination step. The ethyl free radical reacts with chlorine free radical in the presence of sunlight, and there is formation of chloroethane. There is formation of chloroethane, and this step is exothermic and very fast. Exothermic and very fast step. This step is exothermic and very fast step. That is our termination step. So there are three steps. One is the initiation, in which free radicals are formed. That is our endothermic and rate determining step. Second is the longest propagation step, and third one is termination. That is our exothermic and very fast step. So this is the halogenation of or chlorination of ethane. Next we are going to talk about the oxidation reaction of alkanes. Oxidation reaction of alkanes. Oxidation reactions. Firstly, we discuss combustion reaction. This is called combustion or complete oxidation reaction. Combustion or complete oxidation reaction. We have a alkane CnH2n plus 2, that is the general formula of alkane. Then we do oxidation, that is complete oxidation. Reaction takes place in the presence of flame. Reaction takes place in the presence of flame. And there is formation of n moles of carbon dioxide and n plus 1 moles of H2O. If we take the example of methane, that is CH4, C1H4, that is our methane, plus the value of n is 1 here, because n is the number of carbon atoms that we use in the reactants. 1 plus 1 over 2 moles of oxygen in the reaction. Reaction takes place in the presence of flame, and there is formation of n moles of carbon dioxide. We use 1 mole of carbon, 1, and value of n is 1. So 1 mole of carbon dioxide is formed with 1 plus 1, 2 moles of H2O. So this is the reaction. Complete oxidation reaction or combustion reaction, when methane is treated with oxygen in the presence of flame, then there is formation of carbon dioxide with H2O. There are 2 moles of oxygen, 1 mole of chlorine, then there is formation of 1 mole of carbon dioxide and 2 moles of water. balance the equation by using this method, by placing the value of n, how many moles of reactants we take. That is, this is the complete oxidation or combustion. Next is the incomplete oxidation. Incomplete oxidation, in which we give a limited supply of oxygen. We take a methane, then we do its oxidation in the presence of flame. Then there is formation of carbon black with water and carbon monoxide. This carbon black is used in printing. The carbon black that is formed in the incomplete oxidation is used in the printing. Now we balance the equation. We use 3 moles of methane and 4 moles of oxygen. Then there is 6 moles of H2O and 2 moles of carbon monoxide are formed. And this carbon black is formed, that is used in the printing. So this is the incomplete oxidation. Now we are going to talk about the catalytic oxidation. The catalytic oxidation takes place in the presence of a metallic catalyst. The temperature is about 400 Celsius and the pressure is about 200 atm. The conditions for catalytic oxidation. The temperature is about 400 Celsius, the pressure is about 200 atm, and the metallic catalyst is copper. So firstly we take a methane, then we add nascent oxygen. Reaction takes place in the presence of copper at 400 Celsius temperature and 200 atm pressure. Then there is formation of alcohol. Methanol is formed. Then again we add nascent oxygen, same conditions. In the presence of copper, 400 Celsius temperature, 200 atm pressure. Then there is formation of a formaldehyde. Nascent oxygen. One hydrogen and OH eliminated in the form of H2O, and this oxygen adds in the reaction and there is formation of a aldehyde. In the next step, again we add nascent oxygen, then there is formation of a carboxylic acid. Carboxylic acid is formed. In the next step, we again do the oxidation of this carboxylic acid, then we add nascent oxygen, there is formation of carbon dioxide with H2O. So this is the part of catalytic oxidation. Firstly we do oxidation of methane, there is formation of ethanol, then we do oxidation, there is formation of aldehyde, then we do oxidation, there is formation of carboxylic acid, then we do the oxidation of carboxylic acid, there is formation of carbon dioxide and water. So this is the incomplete oxidation. Sorry, catalytic oxidation. This is the catalytic oxidation. Now we discuss the last thermal reaction of ethane. Thermal reaction. Thermal reaction, it is also known as pyrolysis. It is also known as cracking. It is also known as thermal decomposition. It is a reaction in which high hydrocarbons that having high boiling points are broken down into the lower hydrocarbons that having low boiling points. The reaction takes place at 700 Celsius temperature about. Then suppose we have a high hydrocarbon of hexadecane. We have C16H34, that is called hexadecane. Reaction takes place at 700 Celsius temperature. Then there is formation of lower hydrocarbons. This is called heptane with 3 moles of ethene and 1 mole of 1-propene. This is called 1-propene. This is the 3 moles of ethene. This is called heptane. So high hydrocarbon is broken down into the lower hydrocarbons in the presence of heat, in the absence of air. This is called pyrolysis. This is called pyrolysis, breakdown in the presence of heat. This is called cracking, breakdown of high hydrocarbons to low hydrocarbons, or thermal decomposition. Thermal decomposition. So this is the pyrolysis, that is the thermal reaction of alkane. So these are the some reactions of alkanes that we discussed under the suitable conditions. So this is all about the all reactions of the alkane.